Hi everyone. Today we are going to see about building blocks of an algorithm under problem solving using C++. This is Rosalind Diana, Assistant Professor, CSE Department, RMD Engineering College. So what is a building block? Before going for building blocks of an algorithm, what is algorithm? An algorithm is a step-by-step instruction. It can be constructed from any one of the following basic building blocks. So the building blocks of an algorithm are listed below: sequence, selection, and repetition. So building blocks are sequence blocks, selection or decision blocks, repetition or iteration blocks. If you take any algorithm, it will be consisting of, or it will be built based on any of these three building blocks. So basically, sequence block, a common name we will call it as action. Then selection block we will call as decision. Iteration block we will call as repetition or loop. First, we will see sequence block. In sequence block or construct, statements will be executed one by one in the order from top to bottom. So if you take the algorithm for any problem in that algorithm, from the first step, the solution will be there. Okay, it will be solved step by step. The actions are performed in the same sequence in which they are written. So from the first, the sequence will be followed. So randomly, the problems won't be solved in sequence. First statement will have the first solution, that is like input, then execution, then final output. So flow diagram for sequence block, statement 1 will execute first, then statement 2, then statement 3 will execute. So an example is given here: accepting two numbers and find their product. This is the example for sequence block. In the algorithm, we will write the solution for finding the product of two numbers. So in algorithm, first we will write input first number. That name we are giving as A. Then second step, input second number as B. Then third step, you can set the product value as A into B. And finally, it should be printed and the user have to get the result. So we have to print the product. Finally, we can stop the execution. Here, left side, we have algorithm. On the right side, we have the flow chart. Pictorially, it is represented, each step of the algorithm. This is an example for sequence block because first step, accepting two numbers, then calculation, number 1 into number 2, then you're printing the product and we stop the execution. Flowchart contains special symbols for representing input, execution, or processing. We will call it as processing, and the output. Next block is selection block. It is also called decision block. So in selection block, statements are used when the outcome of the process depends on some condition. It is similar to sequential, but we will have some condition based on that a particular set of block will be executed. A condition in this context may evaluate either to a true or a false value. Whenever a true state condition is executed, only that block will execute. For a false block will be avoided. The statement will be executed when the condition becomes true. If the condition fails, the control shifts out of the consecutive statement. Suppose sometimes if the condition is true, we will execute a set of statements, or if condition is false, we will execute another set of statements. That is also possible in selection block. And flow diagram is given here. Condition is checked. If it is true, statement will execute. If it is false, control will move out of the if block, selection block. Example here: accept two numbers, display the first number if it is greater than the second number. Algorithm steps are like this. We start the algorithm, then accept two numbers and store the variables in A and B. If A value is greater than B value, then display A is greater than B. else you have to display B is greater than A. Then we can stop the algorithm. In the flow chart, using special symbols, each step of the algorithm is mentioned. So we input A and B. If A greater than B, true means print A is big. False means print B is big. Then we can stop execution. So any one part of the set of blocks will execute. The third block, final block of building blocks of algorithm is a repetition block. It is also called loops. Repetition involves in executing one or more steps for a number of times. Sometimes same set of statements, if condition is true, we will execute for more than one time. In selection and sequence block, the statements in your problem solving will be executed for one time. But in loop, the same statement can be executed for multiple times if the condition is true. Till the condition becomes false, the particular set of statements will execute. These statements execute one or more steps until some condition is true. Flow diagram is given here. First, we are initializing some value. Then we are checking the condition. If the condition is true, loop body will execute. Your loop set of statements will execute. Each time the condition data will be updated because the loop should not be infinite. It has to stop at one stage. So the condition will be updated each time. If the condition becomes false, then the control will move out of the loop. Example for repetition block, loop block. In this algorithm, we are finding factorial value. So get the value of your input number. For n, number name is n. For n number, we have to find the factorial value. For this, initially, we have to fix the f value. That is the final output value. It starts from 1. And a loop variable here we are setting. Its name is I. I is equal to, initially what value we want to take, we are giving I equal to 1. Then to check the loop condition, we are using I and n. Your initial value I, it is starting from 1. Your factorial value to be calculated for n is n value. So n is equal to, suppose 5 means your I 1. So till I becomes 5, the loop has to execute. So check I less than or equal to n. Repeat the steps 5 and 6. So what are the steps to be executed for this condition? F value, factorial value should be incremented. So f is equal to f into I. So first iteration of the loop, f value will be 1 into 1. Then you have to increment the I value. I was 1. Now I is equal to 1 plus 1, 2. Now in the second iteration, you have to repeat the steps 5 and 6 till I value is less than or equal to n. Now I value is 2. 2 less than or equal to 5. Yes, true. True means one more time these two statements will execute. So I will be incremented continuously. F will also be multiplied continuously. First, our F was 1 into 1. Then when I becomes 2, it becomes 1 into 2. Then when I becomes 3, it will become, F will become 3 into 2 into 3. Then when I becomes 4, it will become 6 into 4. Then that is 24. When I becomes 5, 24 into 5, it will become 120. So this is called looping or repetition. Same set of statements will be executed till your condition is becoming false. At one particular time, I value becomes higher than n. So when I is 5, 5 plus 1 is 6. When 6 is, when you are checking 6 less than or equal to n, it is false. If it is false, condition is false, control will move out of the loop. These two statements will not execute. We will come out and it will print the value of final value f. That is, for example, 120. Then the algorithm is stopped. The flow chart for the factorial of given number for our algorithm is given here. In diamond box, we are checking the condition. In the rectangle box, we are giving initial value. First, we input in parallelogram box, we are giving read n. then initial value you are setting I equal to 1, f equal to 1. If I less than or equal to n, true means you are multiplying f value, incrementing I value. If it is false, we have come to the final stage. So you are printing the f value. Then we are stopping. So here you have learnt about the building blocks of an algorithm, that is sequence block, selection block, and repetition block. Thank you.